Hey everyone, my name is Dima. I'm a senior front-end developer from Berlin with more than 7 years of experience in different companies. In this video, I will show you how to prepare for and successfully pass the front-end system design interview. This video is not about a particular technical topic. Instead, we will talk about the system design interview in general. This video is a part of my course, which I decided to share with you. I will also release a couple more videos from this course in the future, so stay tuned. This is an introduction video, so we will talk about system design interviews in general. Why preparing for the system design stage is important, how to prepare for it and which resources you should use, what types of system design rounds exist, what the main differences are between full stack and front-end system design, and many other topics. My goal in this course is to teach you how to pass the system design interview stage, which is common in many big tech companies. But nowadays, it's not just limited to big tech. Small and medium-sized companies are also incorporating it into their hiring process. For example, I currently live in Berlin, Germany, where there are many large companies like Zalando and N26. You may have heard of them or maybe not, but there are well-known tech companies, though of course not as big as global giants like Google, Amazon or Apple. The thing is, whether a company is mid-sized or larger, they often include a system design interview as part of their hiring process. So even if you don't plan to apply to a big tech company like Google or Amazon, this course can still be valuable for you. Before moving on to the presentation, I want to emphasize why this course might be personally relevant to you. Like I said, many companies today include a system design interview in their hiring process. It has become a very common practice. If you're applying for a mid-level role, or especially for senior and above, you will almost certainly encounter some form of a system design interview. Even if you're aiming for a start-middle role, there is still a high chance you will face a system design-related task. So what about junior developers? Today, there is a noticeable trend of declining demand for these roles. There won't be any ads in this video, but I would like to promote my new application. It's a time tracker called FlowTracks. The core feature is a huge focus on focused sessions, not just tracking hours. It helps you analyze your productive time, find your productivity peaks and pitfalls, see performance over the day, week and month. It even counts the number of pauses, so it tracks how consistent you were during each session, and many other features. I believe this is partly due to the overall economic situation, but it is also closely tied to the rapid advancement of AI tools. In simple terms, companies now need fewer developers than before. It makes more sense for a company to hire one strong senior developer and leverage AI tools to speed up manual tasks, rather than hiring multiple junior developers. Juniors aren't typically given complex tasks that require deep architectural thinking or system-wide problem solving. And while AI tools are improving, they still struggle with areas like communication, cross-team collaboration, and high-level system design. At this stage, AI can't replace the role of a senior developer or architect. It's not capable of making effective strategic decisions, understanding business needs, or effectively coordinating between teams. At least I haven't seen any convincing examples of AI being used that way. But definitely it can help with all these things. This means that for junior and mid-level developers, the best way to stay competitive in the job market is to improve your skills, especially in two key areas. First, you need to learn how to work effectively with AI tools to automate and accelerate repetitive tasks. And second, you need to develop strong system design skills. When it comes to designing complex systems, companies still need real people. Senior developers, architects, and other experienced engineers. Different companies use different job titles, but you get the idea. You might be asking, what if I'm not actively interviewing? Maybe you're not looking for a job right now, so you think you don't need this course. But I would say you are probably wrong. As I mentioned earlier, we're currently in a very unstable economic situation. We have all seen massive layoffs, especially in big tech companies. But this trend isn't limited to them. It's happening across the industry. We just hear more about big tech layoffs because of their size and the media attention they get. But smaller companies are also laying people off all the time. You just don't hear about it as much. So even if you're not actively interviewing, you should still sharpen your skills from time to time to ensure you remain a valuable developer in the job market. If you are in this course, you're probably a mid-level or senior developer, and you have likely gone through many interviews before. You already know that the interview process can be very different from real-world work. In interviews, the focus is on solving specific problems that may never actually occur in real projects. System design interviews, in particular, often feel artificial compared to day-to-day engineering work, where you're typically improving an existing system rather than designing one from scratch. That doesn't mean you shouldn't learn system design. It's not a skill you can master overnight. And while I hope this never happen, if you do lose your job, you will likely want to find a new one as soon as possible. That's why this videos exists. So you can learn now and revisit them later if you ever need them. Now for the third reason why this course is valuable. Even if you're not interviewing and you're not at risk of being laid off, system design is a crucial skill for senior and above developers. Because system design isn't just about the initial phase of the project, it's about long-term development and evolution. As projects grow, they need to be improved, restructured, or scaled. As a senior developer, you will likely be involved in upgrading infrastructure, refining architecture, and launching new services. These happen all the time in the industry because businesses constantly need new features, optimizations, and improvements. And here is the key point. If you don't have the system design skills, you will never be asked to work on these tasks. You won't even be considered because people will know you're not capable of handling them. And if you lack this knowledge, you won't even be able to interpret architectural discussions or contribute meaningfully. But if you do have a basic understanding, even if it's most theoretical, you can start participating in these discussions. You can suggest improvements, propose solutions, and position yourself for bigger opportunities. Why is this important for your career? Well, as I've said before, companies today don't need as many junior or lower mid developers. So if you want to stay competitive and grow as a developer, your goal should be to move up to senior and beyond as quickly as possible. And that's the third reason why this course might be exactly what you need. Okay, finally, we can start. The first thing we need to cover is what system design actually is. System design is the process of planning how different software components work together to meet specific requirements. It's not about isolated solution. It's about choosing tools and technologies that integrate well with each other to form a complex system. For example, in a system design interview or even in real-world system design, you won't be asked what is the best protocol for client-server communication. Instead, you will be asked to design an application where you will need to select the right protocols, tools, and architectural patterns to achieve your goals. The key point is that each part of the application does not exist in isolation. The main goal is to meet the system requirements while ensuring all components work well together. We can generally divide applications into two main types: backend applications and front-end applications. If you are interviewing as a backend developer, you will most likely be asked to design a backend system. If you're a front-end developer, you will be asked to design a front-end application. However, as you move up in seniority, the scope of system design expands. For example, if you're a mid-level front-end developer, the interview will mostly focus on front-end system design. But if you are a senior or above front-end developer, there is a high chance that you will be asked about basic backend topics or even infrastructure-related topics. The same applies to backend developers. The more senior you become, the more you are expected to understand infrastructure, database design, security, and other advanced topics. How to prepare based on your role. If you're a front-end developer, focus primarily on front-end system design, but have a basic understanding of how backend system works. Knowing what happens behind the scenes will give you extra points in interview. Backend system design is a well-documented topic. There are countless courses, YouTube videos, and even official guidelines from tech companies on how to prepare for backend system design interviews. Usually, it includes topics like scalability, application reliability, and performance optimizations. Front-end system design, on the other hand, is a different thing. Client-server communication is a key topic. State management on the client side also should be taken into account. This course is for you if you are preparing for a system design interview. You are a mid-level or senior front-end developer who wants to learn how to build scalable and robust web applications. You want to advance your career by learning front-end architecture. However, this course might not be for you if you are a junior developer still learning the basics. In that case, it's probably better to focus on foundational programming skills and return to system design later. You're looking for a deep dive into specific front-end frameworks like React or Vue. While we will mention React and Vue and other libraries as examples, this course is not about learning a specific library or tool, it's about more high-level knowledge. While we will mention tools like web frameworks, databases, and cloud providers, we will only do so to illustrate key concepts, not to teach specific tools. For example, if we're discussing client-side caching, I might reference Vue query to give you a concrete example. But we won't be focusing on the framework-specific details, only the architectural principles behind them. The first question is, what is system design? I'm sure you already have an idea of what's typically included in a system design interview. In this round, you're usually asked to design an application, but in this section, I want to highlight what system design really means from a front-end developer's perspective. System design consists of both experience and theoretical knowledge. It's very difficult to design an application effectively if you lack one or both of these. The purpose of the system design interview is to evaluate how strong you are in both aspects. To successfully pass the system design round, you ideally need both experience and theory. Experience allows you to go deep into specific topics. For example, if you specialize in high-performance web applications like publicly available websites serving millions of users daily, like Amazon for example, you might have deep expertise in performance optimizations, accessibility, and localization. However, even if you're highly experienced in one area, it doesn't mean you have deep knowledge in every aspect of system design. And here's the issue. You don't know before the interview what you will be asked to design. You also don't know which specific area the interviewer might want to explore deeper. This is why theoretical knowledge is just as important as experience, because no matter how many years of experience you can't have an experience in everything. Theoretical knowledge means you understand key concepts of system design, even if you haven't worked on them directly. It allows you to quickly adapt to new challenges. Let's say you're asked to design a real-time market application, a very common system design topic. Maybe you have never actually worked on a real-time applications before, so you lack hands-on experience. But if you understand WebSockets, how they work, and why they are useful, you can propose them as a solution. Even better, if you also know alternative approaches like long polling or server-sent events, you can compare their pros and cons and justify your design decisions. The combination of deep experience in some areas and broad theoretical knowledge across many areas is what we call a T-shaped specialist. Someone with deep expertise in a few areas and a broad knowledge in many topics. Your performance in the system design interview often determines your starting position and salary at a company. Of course, not every company operates this way, but in many cases, if you successfully pass the coding round, something like lead code style problems or take-home assignment, you will likely get the job, at least for junior and mid-level positions. However, for senior and above positions, if you fail the system design round, you will probably won't get this job, even if you passed the coding round. Even if you don't completely fail, but can demonstrate strong system design skills, the company might offer you a lower seniority level and salary. Most companies have multiple levels within each role. If you perform well in the system design round, you can start at a higher level with a better salary from day one. You might be wondering, is it fair that my system design performance affects my job level and salary? What if I'm a strong developer but haven't had actually designed system design experience in real work? And my answer is, that's exactly why system design is so important. Unlike coding challenges like lead code, where you rarely use those exact algorithms in real-world development, system design knowledge is directly applicable to your actual job. For example, as a web developer, you might never need to implement a complex graph algorithm, but you will need to design scalable applications, make architectural decisions, and choose the right technologies. So if you can pass a system design interview, you are not just good at interviewing, you are also prepared for real-world engineering work. That's why system design isn't about getting a job, it's about becoming a better engineer. The next question is, what is our goal in a system design interview? I would say the goal is to demonstrate as many positive signals as possible while avoiding negative signals. The first positive signal you should aim to show is thinking at a high level of abstraction. In other words, think like a tech leader, not just a developer. Focus on the entire system, not just individual components. This also demonstrates your level of experience. If you spend too much time describing the details of just one component, it might show that you only know how to design one part of the system, which can make you appear more like a mid-level engineer rather than a senior candidate. Of course, this depends on the company, but in general, senior engineers and above think about the system as a whole. For example, you can't just say, I will use React for the frontend, or we will use WebSockets for real-time updates. Instead, you need to consider the bigger picture. How does React integrate with our design system? What UI components need to be supported? Will it meet our performance requirements? And similarly, when choosing WebSockets, will our backend team support it? What are the trade-offs? Is it the best fit for our specific needs? So don't focus too much on individual parts unless the interviewer explicitly asks you to go deeper. Stay at a high level for most of the interview. The second positive signal is showing both broad theoretical knowledge and deep domain-specific expertise. As I mentioned earlier, system design requires both experience and theory. If we think of system design as a graph, it looks like a straight line with deep dives at certain points. You start by explaining the system at a high level. Then, when necessary, you go deeper into specific areas. You return to the high-level discussion before diving deeper again. This approach shows that you understand the big picture, but can also go deep when required. The third positive signal is always considering trade-offs, rather than focusing only on the best-case scenario. Many mid-level or low-level engineers only think about the advantages of a tool or solution without considering its downsides. For example, let's take Next.js, a very popular framework. Many developers choose it as their default solution without questioning whether it's actually the right choice for their specific project. It has great benefits, but it also has trade-offs, because there are no silver bullets in software development. That's the thought that I always try to emphasize in my videos. Every solution has trade-offs. That's why during the interview you need to explicitly discuss the trade-offs of every major decision. For example, if you propose WebSockets for real-time updates, don't just say WebSockets are great because they provide real-time communications. Instead, also mention that when WebSockets might not be the best choice, potential issues, for example, server load, scalability, fallback options like long polling, etc., why WebSockets are or aren't the best fit for this specific case. If you only talk about the benefits of the solution, that's not a senior level approach. There are also negative signals that you should avoid: low-level focus instead of high-level thinking. If you spend the entire interview explaining one component in detail, it signals that you don't see the bigger picture. Narrow technical knowledge. If you only talk about React or any other specific tools, instead of thinking like a web developer or a software engineer or being tool agnostic, you limit yourself. Ignoring trade-offs. If you only discuss the positive sides of a solution without mentioning its downsides, it shows that you haven't fully evaluated your decision. These are the three major negative signals you should avoid. Okay, now we can move on to the main parts of the system design interview. A typical system design interview consists of 5 main parts. Collecting requirements. This is the first and one of the most important stages. At this point, you discuss with the interviewer what is the goal of the application and what are the key requirements. Clarifying requirements early on helps you design a solution that actually meets the business needs. Avoid jumping straight into architecture immediately after you get a requirement. Always start with clarifying questions. High-level architecture. At this stage, you draw the high-level architecture of the application. You should avoid focusing too much on individual components. Show how different parts interact with each other, which modules are connected, what services are used, etc. Think of this as creating a blueprint before going into implementation details. Data modeling. Data modeling is a broad topic. If you're designing a front-end system, you likely won't be dealing with a databases unless it's a full-stack position. Instead, you focus on defining key entities that the application will use. For example, in a to-do app, you might have user entity, to-do entity, and a list of to-dos. At this stage, you show the interviewer which entities the system will interact with and how they relate to each other. API design. This step focuses on how different parts of the system communicate. At this stage, we may discuss how does the server interact with the client, what data is exchanged between the frontend and the backend. You also need to think about API design, considering REST, GraphQL, and WebSockets, data formats, JSON or something different, and error handling and response structure. And the last part, which might be optional, is additional considerations. This final part depends on the application type, but common topics include performance, accessibility, localization, translations, and offline-first strategies. Performance and accessibility are the two most universal topics. Almost every front-end system should optimize for this. To get the most out of this course, I strongly recommend designing real-world applications from scratch. For example, take an app like Figma, Google Calendar, web version of Skype, or any other application you like. Then try to design it from scratch, as if you were in a system design interview. This is an incredibly powerful technique. I've done it at least 10 times before I started interviewing, and it helped me a lot. By the way, some of these real-world examples are covered on my YouTube channel. If you're targeting a specific company, for example Google or Microsoft or Amazon, you can research what they typically ask in system design interviews. Some useful resources for this are TeamBlind, Lead Code discussion forums, Glassdoor, and Reddit. I would recommend to choose from 4 to 5 companies you are interested in and try to find an approach to their system design round. I also have a YouTube video on how to use ChatGPT or I believe any other AI tool for system design preparation. It also might be useful for brainstorming solutions, getting feedback, and practicing different system designs. Here are some real-world examples of system design questions commonly asked at different companies. I found these examples on resources that I mentioned above. Facebook and Meta often asked to design newsfeed, including infinity scroll. Microsoft asks for Google Calendar, like scheduling system, payment system or flashcards in Amazon, App Store architecture in Apple, and video streaming service architecture in Netflix. After designing system on your own, you might want to test yourself with the real-world interview practice. Here are some good platforms for system design preparation: Interviewing.io, Exponent, Prepfully, and of course ChatGPT. I personally had 2 good experiences and 1 bad experience on Prepfully, but in general your experience depends on who are you pair it with as an interviewer. A system design interview consists of 5 key parts: requirements, high-level design, data modeling, API communications, and additional topics. The best way to prepare is to practice designing real-world applications from scratch. Research company-specific interview questions and do mock interviews to simulate real scenarios. Never assume a technology is a silver bullet. Finally, use AI and online platforms to refine your system design skills. The next topic is basics of system design. In a system design interview, you will typically be asked to design either an entire application or a specific feature. Designing an entire application is the broader type of system design question. You will be asked to design an application such as Google Calendar, flashcard application, or a video streaming service. The common characteristic of these applications is that they are large and complex. In this type of interview, you are expected to focus on high-level design rather than getting lost in details of specific components. And the second type is designing specific feature. This type of interview focuses on a key feature of a large application rather than the entire system. Examples include newsfeed, autocomplete, or a data grid component, for example. Even though this is a future-based question, it's still a major component that can take up the entire interview session. For example, instead of designing the entire Facebook newsfeed, including post editing, comments, etc., you will only focus on the core newsfeed functionality. In this case, you will likely be expected to go deeper into internal working of the component, performance considerations, and accessibility optimizations. Rather than focusing on client-server communication, this type of question is more about how the component works efficiently within a system. Alright, let's move to the next topic, the different types of front-end system design interviews. So typically we have got three types of these interviews. The first one is pure front-end system design. This one is entirely focused on front-end topics. If you get this type of interview, expect deep dives into things like performance, accessibility, localization, and other front-end specific concerns. You might be asked to design complex UI solution, things like the infinity scroll or efficient rendering strategies. And since front-end performance is critical, you will need to consider how your solution behaves across different browsers and devices. That means understanding how to optimize rendering, reduce layout shifts, and improve perceived performance. The next type is front-end plus API design. Here you still focus primarily on the front-end, but you also need to think about client-server communications. This means designing an API, modeling data for API responses, and explaining how the front-end and backend communicate. For example, you might be asked to design a dashboard that fetches data from a backend through the API. You won't just focus on UI, you will also need to define how the API should be structured, what data should be returned, and how the frontend will consume it efficiently. And the last option is a full stack system design. This one is mostly for full stack or senior and above engineers. Here you will be asked to design both the frontend and backend. But there is a catch. Due to time constraints, you can go super deep into both. So usually there are two ways this plays out. You provide a high-level overview of both frontend and backend, focusing more on how they interact rather than diving deep into implementation details. Now let's talk about requirements. One of the biggest mistakes you can make in a system design interview is not clarifying requirements up front. If you misunderstand them, you could waste time doing in the wrong direction, and in most cases that means failing the interview. So your first goal is to get clarity on the requirements as early as possible. There are three types of requirements you should be aware of. Functional requirements. These answer the question, what should the application do? For example, a social media app, users should be able to create and edit posts. In a music streaming service, users should be able to listen to music and create playlists. And in calendar app, users should be able to schedule meetings and share their calendars. These are core features. Without them, the application simply wouldn't make sense. Imagine Facebook without the ability to post, it wouldn't be a social network anymore. So functional requirements define the must-have features that form the foundation of the product. The next one, non-functional requirements, the how of the application. These answer how should the application work. For example, performance. Should the UI load in under 1 second? Accessibility. Localization. Does the app need to support multiple languages? This category can also include nice to have but non-critical features, for example offline mode. And out of the scope, what we're not covering. This is the most overlooked part of the system design interviews, but it's really important. You and the interviewer might have different expectations. For example, let's say the interviewer expects user notification to be part of the design, but you assume it's out of the scope. If you don't clarify this, you could end up failing the interview for missing a key component of it. A good approach is to explicitly state what you are excluding. You can say something like, I assume notification and authorization are out of the scope since discussing them will take too much time. Does that sound good? By confirming the scope early on, you avoid misalignment and keep the discussion focused. Once you have collected all the requirements, don't just keep them in your head. Repeat them back to the interviewer. For example, you can say, just to make sure we're aligned, here's what I understand. Users need to be able to create and edit posts, the UI should be responsive and support multiple languages, and we're not focusing on notification. Does that all sound correct? This way you double check your understanding and avoid any surprises later. In big tech companies, you don't just have junior, middle, or senior engineers. There are multiple levels. For example, at Meta, you have got from E3 to E9, each representing a different level of experience and responsibility. A common mistake mid-level developers make is focusing only on the happy path, and maybe that's why they stay at the middle level and can't move on. It means that they think only about the benefits of a technology or an approach without considering trade-offs, alternatives, or potential pitfalls. For example, let's say we need a real-time communication in our app. A mid-level engineer might say, okay, let's use WebSockets and move on. But a senior engineer, they would ask deeper questions like, what are the trade-offs of using WebSockets? What's the cost of maintaining persistent connections? Are there alternative solutions like server-side events or long polling maybe? What happens if a user loses connection? How do we handle reconnections? The critical thinking, evaluating pros, cons, and trade-offs is what separates senior engineers from mid-level ones. If you want to level up, you need to show that you consider different options, not just pick the most obvious one. Now let's talk about signals, basically how your performance is measured. Think of these signals as checkpoints in the interview. There are two types of signals: green flags or good signals, and red flags or bad signals. Green flags add scores, red flags obviously take them away. Green flags: ask clarifying questions. Never assume you know everything upfront. Clarifying questions show that you understand the business side of the system, not just the technical side. Cooperate with the interviewer. Think of the interviewer as a stakeholder or a product manager, not just someone grading you. If you're designing an app, they are the one defining the business needs. Be honest about what you know and don't know. If you don't have real experience in topic, say it. You can mention that you have studied it, work it on a personal project or read about it, but don't pretend to be an expert. Talk through your decision. Instead of just saying we will use SSR, explain why, walk the interviewer through your thinking process, trade-offs, and your reasoning. Now, on the flip side, here are the red flags, things you want to avoid. Jumping straight to design without asking clarifying questions. If you start drawing architecture before understanding the problem, it shows you are just assuming things instead of thinking more rational. Arguing with the interviewer. System design is collaborative. If the interviewer challenges your approach, don't argue. Show that you are open to feedback. Ignoring key questions or prompts. If the interviewer asks you about scalability and you just brush it off, that's a bad signal. Pretending to be an expert in something you're not. If you don't know, just admit it. It's better to say, I haven't worked with this in enterprise apps, but based on what I know, rather than faking expertise. Staying silent for too long. Long pauses make it seem like you don't know what you're doing. If you're thinking, think out loud so the interviewer knows what's going on in your head. Before you start designing the system, you need to ask clarifying questions, because you almost never get all the details upfront. Think of it this way: the interviewer is testing how well you define scope. If you just start designing without asking any clarifying questions, it might mean you don't fully understand the problem. You should always ask at least from 2 to 5 clarifying questions, not too many, not too few. Here are examples of good clarifying questions. Do we need to support emerging markets? Does the app need to be localized and translated? How much data do we expect? How often the data updated? Should users be able to download media files? Asking good clarifying questions doesn't just help you design a better system, it also demonstrates your seniority by showing that you think about real-world challenges. That's all for today. If you like this video, please subscribe to the channel and find me on Twitter and LinkedIn. See you next time. Bye.